You know, Mr. Sams, when I was in high school, I had a calculator that I used for my chemistry class.
Yeah, so did I.
Yeah, did you really?
Uh-huh.
Yeah. In fact, I think this is yours right here.
Yeah,
right?
this is mine from high school.
Yeah, wow.
TI-85.
Notice that his TI-85 has like a graphing feature on it.
Uh-huh.
You know, when I was in high school, no graphing.
No.
No.
At least you had calculators.
I had a calculator. You know, I was
slide
first
rule?
generation with a slide rules. I almost was in the slide rule generation. In fact, I ought to show you a picture. Should I show you a picture?
Sure, yeah.
All right. So if we go right here, here's a picture of our calculators side by side, I think. Go forward, Mr. Slide. Hey, there they are. This is Mr. Bergman's calculator. And you know on my calculator, I should show you this. This is really cool. It would like print out little numbers. It'd like, you know, it'd be, you know, 3 would be like that.
Oh, yeah.
And then 2 would be like that. I didn't do that very well, but you get the idea.
Oh, yeah.
And 9 would look like this.
Yeah, little LEDs.
It was a little LED thing on my calculator.
Yeah.
I even had, you know, all kinds of buttons. I had sine buttons and cosines and tangents.
Yeah.
1 over x, inverse.
Yeah.
Oh, the inverse was such a cool
You know what I
button.
could do on mine?
Yeah.
I could play blackjack during calculus.
Blackjack.
Yeah. See, that was my game. See, the games weren't quite as sophisticated in 1994.
Well, see, mine was a 19. How old? What do you think?
Well, if I was in high school in the mid 90s, you're probably early 80s.
Yeah, it'd be 82 would be my graduation date.
Yep,
So I was using this calculator probably from 79,
See,
179, 1979 to 1982.
I didn't get mine until I was a junior, so 1993 is when I got mine.
1993
Yeah.
to 95. I actually, when I started teaching, I got one of these. Yeah. So I taught people how to use this.
Yep.
Yeah. So that would say that you're like a young whippersnapper, or maybe it says something that I'm old. I don't know. It's one of the two.
I'm starting to feel old, so
Yeah,
I don't
well,
know.
I'm older than you are.
Yeah.
So, hey, calculators. Hey, we're going to use calculators today.
We are.
Pretty
Extensively.
significantly. And we are not going to use Mr. Bergman era calculator. No, no, no. We're going to be using actually a advanced calculator that even kicks Mr. Sam's calculator's butt. So, the kinds that you guys get to use while you take AP Chemistry.
Yeah, it's basically the same calculator, just
Actually,
a little faster and a little
faster processor,
Yeah.
yeah. Okay, so we're going to learn about what's called the integrated rate law. Now, in an integrated rate law, that's going to be a plot of
concentration.
C-E-N. I can't spell today.
You can't
Concentration versus
Time.
So if we look at a graph of concentration versus time, so if I've got a reaction, you know, A plus B turns into C, what's going to happen to A? Let's say A starts out at this concentration. Actually,
Let's not do plus B. Oh, yeah, that
let's
works.
do that.
Okay.
A over time is going to get smaller. But B, if B starts out at, say, a different concentration, it'll get smaller much faster. I didn't draw those very well. This one would actually be more like this.
Yeah.
Ignore this number here. And this one would be twice as fast, hence the 2. But if we plot a graph, this is not a straight line, typically. Actually, it can be. But we are going to, of course, try and figure out what is the equation of the line. So that's what we're going to do.
Yeah.
Okay, now, there are several.
Too far.
All right.
Oh, it is. Okay.
It's just the
it's
fade
fading
out.
weird.
Weird fade. There are, as we learned in the last podcast, you can have a first, a second, or third order reaction.
Or zero order.
Or zero order. So if it's first order, if you're trying to get a straight line, you're going to actually plot the natural log of the concentration, let's say of A, for whatever the chemical is.
Okay.
Where A, concentration of A, could be like, the concentration of some chemical like NO2 or oxygen or whatever the reactant is. It's going to be a reactant, though, versus
time.
That gives you a straight line.
If it's first order, yeah.
If it's first order. And then that leads you to these equations.
Oh, yeah.
Then the equation, when you draw the map, it's actually a y equals mx plus b thing. Y equals mx plus b. And so it will be the natural log of A is equal to negative kt plus the natural log of A original, where k is your rate constant.
Also happens to be the slope of the line.
It's also, K will be the slope of the line. So if we plot this on graph paper or possibly a graphing calculator, we can find the slope of the line. The slope will be the rate constant. And while we're at it, there's a couple other important equations you should know. Something called the half-life equation is equal to 0.693 over K. All right.
All right.
And if I got all of them? Or actually, if it's first order, as you recall, that's where the rate is equal to some constant K times the concentration of A to the first power.
Yeah.
So this only applies to first order rate laws. These are important equations. Now, by the way, in your textbook, and if you're in the 6th edition of Zumdahl, this is summarized on page 578. All right? So if I have a second order rate law, it has a different set of equations. So second order rate law, rate of course, would be equal to K times the concentration of some chemical A squared. Now if you plot a straight line, it will not be natural log.
No, we're doing 1 over the concentration of A versus time this time. Time this time?
Versus time. Okay, and when you plot 1 over A versus time, you get a straight line, and the slope of this line is equal to negative K. And the integrated
Actually,
rate
the
law...
slope is K on this one.
Oh, it's K on this
Yeah, it was
one.
negative K on the last one.
Oh, we better go back and fix that.
Yep.
So this is, the slope is, where did I write that down?
Right down here.
Slope is equal to negative K. All right. So slope is K. So actually I've drawn this incorrectly.
Yeah,
It'll be
line
like
goes
that.
up. There it goes.
It's a straight line going up. And so the integrated rate law is 1 over the concentration of A equals KT plus 1 over the concentration of A original. Now, this, by the way, follows the Y equals MX plus B form, as did the last one. This is your Y equals MX, where X is the time, plus B. Okay? And I think we've got another thing. What's the half-life equation?
Half-life is T1 half equals 1 over K A original. Just like that.
There you go. And there is one that's kind of an odd one. This is the zero order rate law. In the zero order rate law, it is just a graph of concentration of A versus time, and that gives you a straight line. And so you're going to plot just concentration of A. Am I wrong?
Goes down.
Oh, I did it wrong. All right, hold on. So it's actually got a negative slope. Okay. A versus time. So it's just A versus time. And so zero order, your rate is equal to K times the concentration of A to the 0. It actually is equal to K, because A to the 0 power, any number to the 0 power is 1. So that's going to be that. And so you're going to just have, this is just Y equals MX plus B, or the rate law is the concentration of A equals negative KT plus the concentration of the original amount of A. And the half-life equation is concentration of A original divided by
2K.
2K.
2.
This is all found again on page 578 in your textbook. If you're using a different textbook and watching this somewhere else, your textbook on kinetics is going to have this information somewhere.
Yep.
These are just important equations to know. Now let's actually apply those equations. All right. So how do you determine the order of a rate law? First of all, you're going to make a table as below. We'll explain that. And then plot the graphs of each. Now I'm going to show you how you would do this on the TI 84 type calculator. All right, that's what we're going to do here. So these are instructions on how to do this on a TI 84 calculator.
And the instructions are identical for a TI 83.
Also works with 83s and 83 pluses.
I think the 86 is the weird one, or is it the 89?
It's one of those.
One of them's different.
And so most of our students at least have this, so we're going to show you how to do this. There's a bunch of steps to go through, but you can see them, and then we'll actually do them. So here I have a graph, and what I want to, or not a graph, some data on a particular reaction. We're going to take N2O5 and break it down and see if we can determine what the rate law is. Essentially what I'm going to do, let me actually explain this. What I'm essentially going to do, let's figure it out graphically. I'm going to plot the natural log of A versus time. Then I'm going to plot 1 over A versus time. And then I'm going to plot, in this order, of A versus time. One of these will yield a straight line. If this gives me a straight line,
It's first order.
It's first order. This is the first order. If this gives me a straight line, it's second order. And if this gives me a straight line, am I doing it right?
Yep.
It's going to be 0 order.
So 1 will give you a straight line, 2 will give you curves.
So it's going to be, yeah, otherwise it's going to give me a curve, all right? So I need to explain how to do this. And to do this, we're going to zoom the camera in on the calculator while we do this, all right? So let me get to the right thing. Okie dokie. Okay, so now you can all see my calculator. So I'm going to turn my calculator on. Actually, the first thing you ought to do if you got this TI-84 is push the second button and then the catalog button. Because actually what we want to do is something, this is a one-time deal. We need to toggle down. Actually, if I push the D button, as in dog, this is the matrix button, looks like. If I push D, I'm looking for something called diagnostics. And I want to have the diagnostics on, so I press enter. Notice it says diagnostics on, and I press enter, and it says done. That's just a one-step deal. Now, what I want to do is I've got my data on the screen, as you can see. And so now I want to push, as you recall, the stat and then the edit button. It's already chosen edit, so I just press the enter button. And now I have this L1, L2, L3. Now, by the way, if you have something in L1 and L2, if you arrow up, see I can arrow up, I can then push the clear button, enter, and it would clear it. So if I had a bunch of numbers in here, let me put some numbers in here. So enter, enter, enter. So if I have a bunch of numbers in there, if I arrow up and see how the L1 is highlighted, and I push clear, enter, I've just cleared it out. But you want to have your L1s, your L2s, and your L3s cleared. So now what I want to do is I want to enter the data that was in the table, and you can see that. So I'm going to type in the first data point is, actually, do I want time first or concentration? I want to do time, right?
Yeah, I always come back to time.
Yeah, time. So I'm going to go 0. I'm just going to enter the numbers. 0 seconds, 50 seconds. You see it on the screen, right? 100. I'm just entering the numbers. 200, 300, 400. So it's just like a data table, right? And then I arrow over, and now, and I notice I arrowed over. So in L2, I'm going to put the other numbers, the 0.1, the 0.07, 0.0707, the 0.05. I don't put the extra digits if there's zeros at the end. The calculator's not going to recognize that. The 0.025. Hopefully I'm doing these right because I'm kind of at an odd angle.
You're good.
And 0.00625. Now notice here on the calendar, or on the calculator, I have got the same number of data points of each. That's kind of important. So now I've got the data entered. Now what I want to do, okay, is I want to make L3, I want to make L3 something else. So notice how I arrow up, and I actually want to take the natural log of all the numbers in here. And the cool thing is if I press the natural log, notice how it prints the natural log, I can now say the natural log of list 2. Now list 2 is the 2 button down here. Let me get a different pen, it might be easier to see. The 2 button right here, but it's the L2 there, so I push the second L2 button. Notice what prints here, close the parentheses, and press enter. Now if you look on the screen, it has taken the natural log of 0.1, it's this number, the natural log of 0.07, etc. Now I want to do one more. I'm going to arrow over, and I'm going to make L4 to be equal to, this is for second order rate laws, 1, notice
Real
here.
quick, before you proceed, notice that the cursor is right here.
Yes.
He had to arrow up to get it right there in order to do this calculation.
Yes, exactly. 1 divided by the concentration. Now the concentration, as you recall, was the L2. So I'm going to do second function, L2, close my parentheses. Actually, there's no parentheses. And press enter. So what this just is, it took 0.1, or 1 divided by 0.1, which of course is 10. 1 divided by 0.07 is 14, etc. So now I have a whole bunch of data in my calculator. Now I want to see which one yields a straight line. Now this is a graphing calculator, so it can graph. So that's a cool thing, right? So I'm going to quit, second quit. And now I get my thing out. Let me clear my screen. Now to do graphs, we're actually doing a statistical graph, or a stat plot. So I'm going to push the stat plot, but you actually have to push the second stat plot. Now I've got a bunch of plots here. I'm going to just select plot 1, press enter, and I want to turn it on. Now it's on as opposed to off. And I can do a graph of L1 versus L2. Now to see this graph, we're going to push the zoom button. So I push the zoom button, and I need to have it sort of, there's a thing called zoom stat, which is number 9. And I press enter, and now you can see the graph. Notice, is that a straight line?
That is not a straight line.
Not a straight line. So that was L1 versus L2. All right.
L1 being time on the x-axis and L2 being just the straight concentration. So if that yielded a straight line, it would be 0 order. But it didn't, so it's not.
Actually, something we should do on the screen here, L1 was time. L2 was concentration. I'll just write concentration of the N2O5. L3 was the natural log of the concentration, and L4 was 1 over the concentration. It's good to write that down. So we just plotted L1 versus L2. If that had yielded a straight line, it would have been what order, Mr.
0
Sims?
order.
0 order. But now we're going to plot time versus natural log. And so if this yields a straight line, so then I go second stat plot. I've already got the stat plot on inner, but what I want to do is I don't want to L1 versus L2, but L1 versus L3. Now to choose L3, here's the L3 button. It's underneath the 3 button right here. So I'll do second function L3. And notice on the screen it says L3. Then I push zoom, and then I do zoom stat. So I toggle, actually I can toggle up, it's faster. Zoom stat. Ooh,
that looks pretty straight.
Looks pretty straight.
Let's
well,
double check the other one, though.
Let's do the other one. So I do the same thing. I go second function stat plot, inner. And now I do versus L4, so now I've highlighted the L4, so I do second 4, notice L4, and I do the zoom stat. Oh, that's a curve.
Yep, that's not straight.
So it was the second one.
Yeah, the L3 versus L1.
So we would say that this is a first order reaction. Now, but we care about more than it just being a first order reaction. We also care what the rate constant is.
Yep.
The cool thing is on the calculator we can do that. So now back on this calculator, if I now go stat, not edit, but calc, I arrow over and say calc, I then can go down here and choose the linear regression or lin reg and inner. Now I can say, I can do L1, so second L1. Actually I'm going to do like, and I'm going to type comma, use the comma button right here, and I'll do second L3. That's what got me the straight line. And some very interesting things come up. What you can see is that we get this equation, y equals ax plus b. A is the slope, and it's negative 0.0069. What is A, the slope? Slope is negative k in this case.
Yep.
And actually, let's talk about these r's and r squareds. This is actually doing a statistical analysis. The one that gives you the closest value to 1 is the one that wins, that gives you the straightest line.
Yep.
If we had done this with the other two, you would get a number that would not be as close to 1 as this is. So, therefore, this is close. And then, therefore, the rate constant for this reaction, all right, let me go to a new screen here. No, not that one. Well, I'm going to leave it here, I guess. The rate constant, actually the rate would be equal to K times the concentration of N2O5 to the first. And K, in this case, would be equal to 0.007, 0069. Now, notice I didn't put the negative sign. Actually, with rate constants, I always remember rate constants are positive. If you get a negative slope, it's positive. If you get a positive slope, it's positive. It's like absolute value. Okay? Let's do another one like this. So let's take a look at this reaction. It's the same thing. Now I need to just enter the data, and let's see if we can find the rate constant and the rate law. So I'm going to go back, and actually I'm going to do this a little bit differently. I'm going to do stat, edit. I did calc, enter. Now notice all my data is up there. So what am I going to do? I need to clear it out. So I go up to L1, push clear. Go up to L2, push clear. Go up to L3, push clear. And L4 is kind of off the screen, but I want to clear that too. So L1 is my time, so I got 0, 1,000. All right, I paused the video and I put all the numbers in. You really should do this, guys, at the same time. You have to learn how to do this with your calculator, so you should have your calculator out. Now I've got the numbers in there. I now need to make my L3 the natural log of L2. And I need my L4 to be 1 divided by the natural log of L2. Not just of L2, not the natural log of L2. So I've got all my numbers in there. Okay? So you need to do this. I went very quickly, but pause the video, rewind, whatever you need to do. Now what I'm going to do is I'm not going to plot the graph graphically. You can if you'd like. But actually, if I can find the number that has the closest value to 1 in that whole statistical thing, I'd be good. So if I do stat, calc, now I can do that right.
Wrong one.
Stat, calc, linear regression. That's what I want to do. And then I'm going to say L1 versus L2. So I'll do second L1, comma, second L2. I push enter, and here's my equation, y equals ax plus b, but look at my r value. It's 0.903. Well, 0.903 is not very straight. It's kind of close to 1, but it needs to be like 0.9999. So that's not a very good one. So let's do the next one. So I just do the same thing, stat, calc, linear regression, and I'll do second L1, comma, second L3. This is the one that worked last time, right? And my r is 0.975. That still is not very good. I want to get one that's 0.999. So probably this is a second order rate law. So then I go stat, calc, linear regression. You just keep trying to find until you get the right answer. And I'll do second L1, comma, second L4. And now look here, 0.9999. So, and what is my rate constant, or my slope? The slope is A, and A is 0.06. So this particular rate law would be rate is equal to K times the concentration of the C4H6 squared, because it's a second order rate law, and K would be equal to 0.06. And it's second order, so from our last podcast, you could determine the units on that. Okay, this would be a liter per mole second, or where'd my pen go? So it'd be 1 over molarity second, right?
Yep.
Okay. All right, now back to a full screen view. Yeah, this is just that summary table I was telling you. I'm not sure it's on page 572 anymore. That might be an old book. Who cares?
Yeah, we showed you the page number.
You saw the page number. All right. Now let's do another example using half-lives with the integrated rate law. So what is the answers to these questions? If we have a first order reaction, so it's first order, so it applies as a first order rate law reactions. It's complete in 480 seconds. Calculate the rate constant.
Okay.
Well, in this case, we're going to use that equation. Since it's first order, the natural log of A equals negative KT plus the natural log of A original. We're trying to find the rate constant, okay? But what we've got is we have it's 38.5% complete. Well, the original amount, a nice thing with the original amount, you can assume it's a percentage. So I'm going to say plus the natural log of 100. And then equals negative K times the time, which was 480 seconds. But this is going to be equal. Now, we've got to be very careful on this. If it's 38.5% complete, what is the percentage that you have right now?
It's 100 minus that.
Yeah, so it'll be like 62.5, 61.5. So the natural log of 61.5. You have to read these questions carefully. If it says complete versus, what would the other way? If it's 38.5% remaining, then it would be 38.5. It's the remaining that matters. And now we simply solve for K. Now, what's the log of 61.5? Natural log.
It is 4.12.
Equals 480, negative 480, 80 K. I'll just rearrange that. Plus, what's the natural log of 100?
2.24.
2.24. So you would subtract 2.24 from both sides. 4.12 minus 2.24 is what?
1.88.
1.88 would be equal to negative 480 times K. That doesn't sound right, Mr. Sams.
So divide both sides by
1.8 or 480 negative, but we should get a positive answer here.
Yeah, something's weird.
What did I do wrong, Mr. Symes?
Let's hit pause and figure it out.
4.65.
Ah, we found our mistake.
Mr. Sams can't use a calculator very well. This number is 4.61. So we're going to subtract 4.61 from both sides. So 4.12 minus 4.61 will give me a negative answer. What is it?
Negative 0.49.
Negative 0.49. Divide both sides now by 400, negative 480.
And we get 1.02 times 10 to the negative third. That's more like it.
And that would be the value of K. Now, that's just question 2. Question 3 says calculate the value of the half-life. The half-life is an easy equation. All right, the half-life equation, if you recall, T1/2 is 0.693 over K. So that'll be 0.693. What was our K?
I don't remember.
1 point something.
1.02 times 10 to the negative third.
Yeah, so this is 1.02 times 10 to the minus third. So what is that? 679.
79.
And I forget our units.
I think we're in seconds, maybe. Yep,
seconds. So it'll be seconds because that was in seconds. So that's the question. Let me apologize. We're jumping back and forth. Now we've answered question 3. Question 4, how long will it take for the reaction to go to 25%? So in this case, we're trying to get to, actually, there's a really short way to do this. All right, let's actually talk about that. Go forward. I need a blank screen. All right. All right. If it's going to 25%, that's a nice thing because what does half-life mean, Mr. Sam?
Half-life is the time it takes for it to go to half of the original value. So if we're trying to get from 100% down to 25%, oh yeah, the table. So at time 0 we have 100%. Now after one half-life, that's down to 50%.
But one half-life is 480 seconds.
No, 679 seconds.
It'd be 679 seconds. That was the other number.
Yep.
Okay, and so that would be at 50%.
50%, right.
And since they're asking for 25%,
that's half of 50%. So
that'd be 2 half-lives, so that'd be 25%. And so 679 times 2 to 12, 1,300.
1,358.
It's 1,358 seconds. Now, let's just for fun do this mathematically with our equation, just to see if we get the same thing. We could say the natural log of, now it's very important, is it going to be 25 or 75?
It's going to be 25 because we want to know when it's 25% left.
So the natural log of 25, it would be equal to negative, and the K value was 1.02 times 10 to the minus third times T plus the natural log of 100. Right? And when you solve for T, you better get 1,358 seconds, or we did something wrong.
Yep.
But mathematically, you can solve it this way, too. But if it's an
look at that, 1,359.
Amazing, 1,359. I can live with one extra second. All right, you get the idea here is that if it is an even number of half-lives, this table guy makes life so much easier. Okay? All right, the next question, how long will it take for it to go to 75%? You know, Mr. Sams, we got these wrong. To go to 25, that means...
Yeah. Right.
Yeah, you're right. Okay. Right. And to 75, 75 is not going to be an even number of half-lives.
No, it's not.
So we're going to have to say the natural log of 75 is equal to negative, was it 1.02? What is that number?
Yeah, 1.02 times 10 to the negative third.
1.02 times 10 to the minus third times T plus the natural log of 100. You solve for T, you can use your solver however you want, and you get 282 seconds. And then lastly, I think there's one more question.
95%.
95%. It's using the same equation, isn't it?
Yep.
The natural log of...
95.
No, Mr. Sams, I think we're doing this wrong. This should be the natural log of 5.
No.
95% complete, not to 95%.
Well, it doesn't say that.
Yeah. Depends on how, you got to read the question. It's not very
it would be worded better on the AP test.
Yeah, we're not wording it very well. It could be 95, but if it's 95% complete, it would be 5.
Right, 5% left.
5% left. But just negative.
If it's going to 95%, that tells me that it's going to 95% of the original value.
I think I meant the reverse when I made this problem up. Because I wrote this problem.
Say what you mean,
I know
mean what you say.
I know. And this is going to be a very short period of time.
50
seconds.
Yeah. So yeah.
But read the question
carefully.
The semantics really matter here.
They do.
And of course, I wrote the question, didn't write as well as I should. Well, I meant to go to 90%, 5% completion. And then, of course, that would then be a 5. But it's the same math, guys. You would just plug in, instead of a 95, here you'd plug in 5. So it's not terribly difficult. Well, we hope that you have learned much about the integrated rate law today.
And your calculator.
That'll
be your friend. Make sure you know how to do that. If you did not follow along with your calculator, I would go back and rewatch that section with your calculator.
With your calculator in hand and practice. Now, if you've got like a Casio calculator or another variety...
You can do it on there. We don't know how.
Well, I figured it out, but it's a lot of work. I recommend you go buy a TI-84 calculator because they seem to work the best. All right, well, have a great day. Bye.